the man himself. So everybody knows Andreas. Thank you. Andreas, Lustre 217 and beyond. Take it away.
Thank you. Hi, so I have quite a few slides. I'll try not to spend too long on them, but if people have questions, feel free to ask. So I think probably for this audience, people know Lustre is widely used. We just had the statistics compiled by Peter Jones for the top 500 list at supercomputing in November. And this year, 9 out of the top 10 systems using Lustre. We're still around 65%, I think, of the top 100. Very good adoption in the AI market, which is really nice to see. I mean, it's partly because AI ends up being very similar to HPC workloads in terms of I/O performance requirements and things like that. And Lustre can, I sort of joke that Lustre, the scalability limits are mostly defined by people's bank accounts. But the scary thing is that some of these AI companies, they're pushing the limits of that, right? They're, spending billions of dollars on GPUs. And so we'll see just how big it goes. I'm actually hoping that, in the upcoming year, we might hit a 1 exabyte file system. I'm not totally sure, but it would be interesting to see. And the power of these the GPU nodes is pretty significant, right? Not petabytes, but 1 or 2 terabytes of RAM and hundreds of CPU cores. One of these systems is as much as a whole supercomputer was, 10 years ago, right? So we do have to do a lot of work to continue to improve the performance of Lustre. We don't, just because the hardware is getting faster doesn't mean that the software immediately, gets the same performance. We have to do work for multi-threading, improving the locking, efficiency and things like that to keep up with all of these improvements. And so, this is a diagram you've seen before. I won't go too much, but we're trying to make sure that Lustre is managing the storage in all of the different areas, right? Storage inside the servers is pretty interesting these days. For the, all of the GPU boxes come with 8, NVMe drives in them, but in some sites they're just, space heaters because it's hard to use them, right? And so, we have the persistent client cache is actually being used in Lustre to utilize the in-node storage. Migration across the tiers, we've talked about that, so I won't get into too much. Last month, we did make a GA release for 2.16. It's unfortunately been almost actually over 2 years since we made the 2.15.0 release. And this was slower than what we had hoped, but one of the big issues there was the IPv6 feature, and it was holding back the mainline release, but it's finally done, and we had to make a quick little fix, 2.16.1, to fix a critical bug that we had found before testing. We thought it would have had a very isolated scope, but then after, of course, the day after we released it, then we got a notification. It was like, oh, this applies to everybody, and so we made a quick fix. That doesn't necessarily mean that it's an LTS branch. There's not necessarily going to be regular maintenance releases for 2.16.0 yet, but you can see the contribution. DDN, Whamcloud, still traditionally the biggest share of contributors, but we're getting a very good contribution from different organizations, and so this is nice to see that there's other contributors. I'm not against external contributors. I mean, every line of code that somebody else writes is one that I don't have to write, so no complaints there. And I've given previous presentations on 2.16 features, the big ones being RHEL 9, IPv6, was the big long pole to getting this one released. And we had another feature optimized directory traversal, which I'll talk about in a minute. So going forward, the 2.17, we already have features that are, largely already the development is completed because the 2.16 release took so long. Some of them are already in the tree or starting to land. Hybrid I/O is made it mostly into 2.16. Dynamic node maps is well underway, and client-side data compression is largely working, but these are not yet landed into the master branch. We also have other features, and I'll get into the details of these ones, but we have other features that are either substantially, started development or with good planning, and then a few features that, we have an idea that people will be working on these. I'm not a pie in the sky kind of person. I only list the features when people are, reasonably expected to be working on them in the time frame that's coming up for these releases. So, the big one, IPv6, we were working on this for a few years, and it's not just, there's only a few lines of code actually down at the very bottom level about how to establish the connections to say, oh, this is an IPv6 connection versus an IPv4 connection. But there was quite a bit of work around that related to configuration. How do you make these things, compatible between different releases, and making sure we didn't have a flag day where people that have 10 file systems connected to 12 clusters and things like that. It's like, oh, you just have to upgrade all of your clients and servers on the same day, right? That's not going to be a practical solution. So we do have, there's a bunch of work to make that compatible. As well, there's, work to be done about how to handle the large NIDs and the configuration. We're trying to simplify this. And there's going to be ongoing things in the 2.17 release. Really, we want to try and get, we did this work to allow the IPv6 NIDs to be stored in the configuration, but we actually want to try and get rid of that so that the system is more auto-configuring, and the goal being that you should just be able to start up a Lustre server somewhere. It should advertise its own NIDs to the MGS, and then the MGS will pass it on to the clients. And this will help us quite a bit with multi-tenancy, which is something that is increasingly popular in large deployments, is being able to isolate groups of users, and they each have to have their own NIDs. So we may have servers, despite the fact that back in the early days of Lustre, we thought, who's ever going to have more than 32 network interfaces on a server? And so the physical network interfaces are still fine. We don't have people, you'd have to have 32 slots. But the virtual interfaces, we're probably going to have systems with a couple of hundred or more virtual interfaces. And so we have to be able to handle that, more easily. Hybrid I/O, this is a whole presentation about this from Patrick Farrell at the Lustre user group. That's worthwhile, and he's a very good presenter. The important thing being that this is hybrid I/O is about trying to make the decision for you between buffered I/O and direct I/O, right? And just like progressive file layouts was taking the decision between one stripe and many stripes sort of out of the hands of the users. They don't have to think about that. And hybrid I/O is taking away this decision. Should I do direct I/O, for this workload? And the interesting thing about this is that after about a megabyte I/O size, on the left-hand side here, buffered I/O is better up until a megabyte, and then here's this curve saying, oh, direct I/O is bigger, is faster, at a few megabytes I/O size, but right now the application has to make this decision, and so we want to do this in the kernel. And it turns out that the data copying, people traditionally thought that the data copy was the expensive part of buffered I/O, and going to direct I/O, eliminating the data copy was where you got your performance win. But the actual truth behind the matter is that the data copying is only about 10% of the difference, and most of the overhead is putting pages in and out of the page cache in the kernel. And so we can still do the data copy because we have to have the data aligned. You get some random chunks of memory from the application. It has to be aligned to the I/O size when we send it over the network to the server. But you can still copy into a temporary buffer, send the network request, and then put that buffer away, and you get all of this performance gain. And this is the limitation of the buffer cache, because at gigabytes a second, you're putting millions and millions of pages in and out of the page cache continuously just to get that bandwidth. And so, this graph shows 19 gigabytes a second with the direct I/O. And this is, granted, this is not a normal I/O size, to do 1 gigabyte I/O sizes. But, if you can get, 19 gigabytes a second, this is one stream doing like DD, right? And so it's worthwhile to look into this. And there's actually, if you have enough network interfaces, this can get up into the 40, 50 gigabyte a second range from a single thread doing I/O. So it's definitely worthwhile improvement. Lots of other kind of small improvements that have been done, and like I said, sometimes it's the small things. These are lots of little projects that were done, in the last year or two, and just adding little options, LFS find minus printf, so you can get formatting. You can say if you're migrating, you want to rebalance. I just added 20 new OSTs and I have 40 full OSTs. So I want to move, 50% of my files over to the new OSTs, or 30%. And so you can say, find but skip, 30% of my files. And so migrate only a fraction of them. And weird little things like this. And so, we just added a whole bunch of new little improvements. I mean, little plug, my kids were working for a DDN this summer, and so they, we had all of these outstanding little improvement projects, and so they were interns, and so they did some of these ones, not all of them. These come from a bunch of different contributors, but it's nice. These are great things for administrators to simplify their life. And other kinds of bigger things, 8,000 device limit. You'd think, okay, how many people have 8,000 OSTs in their file system? Not too many, but it turns out that if you're running Kubernetes or something like that, and then each pod, mounts 1 or 2 Lustre file systems, and there's a few hundred OSTs on each of those file systems, suddenly a single node can have thousands of devices. So static devices removed, a bunch of other things. Quota aggregation, again, this is helping virtualization. And erasure coding has another feature, which I'll get to. Client-side data compression, this is a big new feature that has been worked on for the last year or so. Related, in order to allow the file to be handled in random I/O fashion, we split up the file into smaller chunks, right? And so every 64K chunk by default gets compressed separately, and the client sees, the application sees just a nice, normal I/O path where they have, the page cache has uncompressed data in it. But behind the scenes, the chunks are getting compressed into smaller, units of space, sent over the network and stored on disk, right? And so this feature works with LDiskFS. ZFS already has server-side compression, so we haven't integrated it with ZFS yet. But on LDiskFS, we can get, good space savings. I'll show you the ratios here. It's between, depends on the data, of course, but we're using all of the standard algorithms, LZ4 and gzip, Z standard. And so we can get between, average about 2 to 2.5 times compression. In some case, I guess I don't have the other graph here, but in some cases as high as 5 or 6 times compression, depending on your workload. And because it's being done, the compression is being done on the client side, we have lots of CPU cores there. And so the performance is, on a single stream, it can be reasonably good, but as you get larger numbers of clients doing I/O, then they can compress the data quite well without, without slowing down the file system. As well, there's other workloads that we've done improvements on. One of the things that came out with one of our AI customers was related to using Apache Spark. And it turns out that this is doing a lot of renames in the path. It's actually kind of crazy. They're working around problems with Hadoop and S3 where they don't have POSIX I/O, and so you can't depend on the file sizes and the data to be, consistent when you access it. So they actually stage all of the data into a temporary directory, and then once all of the data is there, they rename it out of the directory and start processing it. And so basically every single file that gets added into the file system has a rename operation. And so for 20 years, HPC apps didn't do this. And so, we got to this workload and it was making the MDS, pretty unhappy. So we've added parallel directory and file renames. It doesn't affect every single workload, but you can rename inside a single directory in parallel across the file system. You can rename from a regular file from a subdirectory to the parent without doing a global file system lock. And so this, removed the performance issues that we saw. I guess I don't have time to go into all of them, but, a number of other improvements on the server side. Again, usability, I mentioned during the discussion previously, pool spilling, right? So that you can spill from a flash tier to a disk tier if you run out of space. Online addition of MDTs and OSTs, so that if you're expanding the capacity of your file system, this is handled transparently now. LL JobStat, a little plug. This is a good way you just can run it on a server, and it's like a top kind of thing that tells you which job is using the most, RPCs. So it's easy to find bad actors in the file system. What else? Multi-tenancy. I think Matt's probably going to talk about this. There's a number of things. It's a very hot topic in the file system world. So we're doing a number of things in node maps to improve multi-tenancy. And I'll leave this part to Matt. What else? Metadata server improvements. So just better recovery. In terms of handling errors with the logs or D&E, right? And so, we have systems now with 30 or 40 MDTs in them, and that's, needs to be pretty solid when they recover. A nice little debugging thing is storing the job ID into an XAdder so that if you run some, you run an MPI job, you can actually find out which job created those files after the fact. Helps users and helps administrators figure out issues with the file system. And then one of the things that we're going to be working on in the future is improved redundancy for the MDTs. Starting off originally in the first phase, just sort of decoupling some of the services that currently run on the MDS, like having a redundant MGS, having the quota be decoupled from MDT0 and things like that, just to make it easier to run. And then, this is a bit of pie in the sky, but we will start looking at making redundant directories as well. And so, this is going back a little bit. This is IO 500 scores over time by Lustre version. And the hardware is not sticking exactly the same between versions, but the reason for this slide is mainly to show that there are things that we're doing in the software that are actually giving us significant improvements on the performance over time, right? These things are showing speed ups, in some cases 50 times speed up, but over aggregate 2.6 on the IO side and 6.6 on the metadata side, right? Those are not just for performance improvements from the hardware, but also improvements in the software. This was so metadata write-back caching. This is quite an interesting feature that we've done a lot of development on, and it's prototyped, and now it needs to be hardened for production and landed into the 2.17 release. And basically the idea, which can be explained simply, is that you can create files and directories in memory on the client without doing any RPCs. And so it starts off, if you create a new directory, that client can have an exclusive lock on the directory and go crazy creating files and directories. Let's say you're doing untar or something that's common in some workloads. You create a new directory per client, and they can get very good performance and then flush the data back asynchronously. If you consider it similar to if a client was doing 1 byte writes and you did a synchronous 1 byte write to the server every time, that would be bad performance. And it's sort of similar to how MDTs are working today, right, with creating files. And now we're essentially saying, okay, you can create, do 1 byte writes in memory, but you're writing megabytes at a time to the servers. And that's what metadata write-back cache is doing. And so we do actually have code that's implemented a lot of this. There is productization that needs to be done, but the numbers are pretty compelling, right? So it's saying that, from regular Lustre, this is, 3,800 creates a second, up to, and of course the bottom of the graph is a little bit chopped, but 370,000 creates a second, 750,000 stats per second from the client cache. So this is pretty compelling to get this into production, and we'll be working on that in the 2.17 phase. The other area that's quite interesting is erasure-coded file data, and so this is again something we have a prototype on, but needs more work to be productized. And so the basic description is you'll be writing files. To start off, they'll be RAID 0 like they are today, just striped data across OSTs, but then you'll be able to add in erasure-coded parity, after the fact. And so this doesn't slow down your initial file creation, but then you can add in parity for redundancy, within a couple of minutes of the file being created. And so that gives you, the redundancy you need for OST failures and things like that. It's not, let's say, Lustre's not used for banking transactions and things like that. So if there's a couple of minutes where you don't have redundancy, you still have the RAID at the backing storage level, but it's enough to get you through issues when the OST is offline because of hardware failure, because of drive failure, or something like that. And so again, this is something that is under development already, but not ready to go out of the box. And this is now into metadata redundancy. This is where we're just starting the development. We're starting in the 1A phase. I always like to split up everything into bite-sized chunks so that we can get something out the door in a reasonable state and give you incremental improvements. It's not going to give us everything at once, but times change, directions change, priorities change. So if we can make part of this work done now, we'll have the at least some of the benefits if it doesn't quite make it. So like I said, The LMR1 is the replicating services to, other MDTs. We've already, actually in parallel already been working on transaction performance. So the good news is the underlying mechanism to do the directory mirroring, it already exists today, right? So when we do a rename, when we do a hard link from one MDT to another MDT, we're already doing these distributed transactions. And we just have to say, oh, I'm not making a hard link, I'm just making a copy. It's the same thing, we just don't remove the original link, right? And so we have all of the technology to do mirroring, but it's not wired in a way to do the actual mirroring, and then you have to, productize that. How do you recover from a broken MDT? How do you rebuild the failed MDT, right? And so that part still has to be done, right? And so that's, going to be, I don't know, a year or two of work, but, it's on the horizon at least. And, as a parting little comment, I mean, people always say, oh, POSIX, is it going the way of the dodo bird, right? Is it the same as Fortran and tape, right? That, is it going away? But I think that POSIX has been around for many years and will continue to stick around. And, there are people who say, oh, we implement POSIX, just a small subset of it, right? And that's fine, but, users don't know what part of POSIX that they need. They know it works, they know their application works. And so my preference is that we have POSIX, and then if your application, you need this kind of workload or that kind of thing that just gives you the additional performances, you should be able to opt into those changes rather than saying, oh, if you do this thing, it's broken, right? And so applications that know what they want or libraries that know how their workload is, they can choose to use the extensions. Like IOU ring, for instance, is a great, alternate I/O path, and it has its benefits, but that's not thrust upon the applications that don't need it. And I think that's the last of my slides. Oh, this is a plug for other events, but we can take questions now if there's any.
Andreas. I'm sure there'll be a couple of questions Gareth will lead back, but I think if POSIX is going the same way as tape and Fortran,
exactly.
If those are kind of the most to use things in the world,
Yeah.
It's got a long life ahead of it.
Yeah.
A couple quick questions, if there are any. Probably lots of things to think about. Alistair. Been very good for the questions this year. It hasn't been a struggle at all.
What would the recommendation be if we were setting up a new Lustre system on a Red Hat 9 server? What server version would be the one to use?
What do you mean?
Well,
Just
should we try and stick with an LTS? Maybe that's not available on 9, is it?
Yeah,
should we go for 216, 217?
Well, 216, is the only one out. 217 is, at least a year away, right? So, 216 is the only one you can use for EL9 and variants today. It's pretty solid, right? The testing for Lustre releases is way better than it was years ago, right? And we did have, there was time on large Cray systems and things like that with 216 before it was released. So it's pretty solid. It's just that I don't think any of the vendors support it yet. It's just only a few weeks old, right? But that doesn't mean it doesn't work, right? It's just, not necessarily going to get support updates, right?
You're trying to pass on to John.
So it's kind of related. Have you made a decision about what the next LTS is going to be?
So that's a Peter Jones slide question.
Right, okay.
And the answer is no. Like there was a questionnaire last year in March that people asked, should 216 be LTS? Should we be 217 LTS? I think the demand for more frequent releases is down because the stability is there and people have they don't want to have a churn of upgrades. So we haven't made any decision yet. I think it will depend on, do the vendors pick up a specific release, or is there some, feature that everybody wants, right? Does everybody want to wait for erasure coding, let's say? Then it would make 2.16 a bit premature, but 2.17 would be the one, right? Assuming erasure coding is there, but, there's no decision yet.
Any more for keeping Gareth fit?
You should alternate on the other side of the room so we get the most
Absolutely.
exercise here.
So just to confirm, can I now deploy 2.16 in an IPv6 only environment?
Yes, I mean, you have to have 2.16 clients and servers in an IPv6 environment. It does work with IPv6 only. I don't know if it's IPv6 and InfiniBand would work, but definitely IPv6 with Ethernet, right? But I'm not a network person. I just know that people we do have test options that say IPv6 only, right?
I think there was a...
Is that bug in 2.16.0 client-side or server-side or both?
Sorry, is the what?
Is the bug in 2.16.0 client-side or server-side or both?
Sorry, I still couldn't understand.
Is the bug in 2.16.0 only apparent if you use it for a client or the server, or both?
In the 2.16...
If I have 2.16.0 on the client...
Oh yeah, the interoperability is I mean, Lustre has very good interoperability.
There's a bug for 2.16.1.
Yeah. Oh, the bug for 2.16.1. Okay, so then it's a I believe it's server side. Yeah. So it happens in a very specific set of circumstances. You have to have a progressive file layout, and then the MDS crashes right at a certain spot, and then it does need a fix on the server side.
Okay. Oh, and then
Yeah,
one last...
yeah,
One last from
in
Alistair.
traditional
But there
format.
will be a short panel session
Yeah.
as well, so if you think of anything.
Yeah.
You mentioned for the erasure coding
Yeah.
that you should still have it backed by RAID.
Initially, yeah. I mean, it's going to be brand new, right, when it comes out.
Okay, but the intention is
Yeah,
eventually...
and so the initial phases, it's the same as FLR mirroring today, where I call it delayed mirroring, right? It'll be delayed erasure coding. So you won't have redundancy of your data immediately, but it would be generated within a couple minutes, depending on the tools that are running. But the other thing that's, I think, would make me reluctant to say you could do the whole file system with erasure coding only at the Lustre level is that the tooling and things like that for whole OST failure is not really there, right, for most cases. The initial phase is what I would sort of call like read-only erasure coding, right, in the sense that if your OST goes away, you'll be able to access your data and things like that. But if a whole OST disappears, you would have to go through and rebuild all of your parity and things like that. And that part of the development is not going to be in the first release, right?
Yeah, there's one very quick one, then I'll move on.
I'll just save Gareth from doing some running. On the compression,
Yep.
are you going to be able to turn that on and off by application? Because if I'm already writing out data in a compressed Lustre.
Yeah. So it's part of the file layout. So it'll be in the same manner as striping, right? So you can either set it on a whole file system, on a directory, on a file. You can even set compression on a component, right? And so it will also detect if the data that's coming in is already compressed, it will stop trying to compress it.
How
right?
will it know? Now I'm intrigued.
Oh, it tries to compress the data, and if the compression ratio, if it doesn't compress,
okay.
it will just stop doing
Okay.
it.
I think with things like BAM files for genomes,
Yeah.
indexable compression is also very
for sure.
important, being able to index in before you
Yeah,
start.
and so you could have the header be uncompressed and the rest of the file be compressed.
Yeah, no,
It's
absolutely.
very good.
Thank you once again, Andreas, but I think we're back to the panel.